Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Ahmad Alif bin Nawi. I am a final year student from School of Mechanical Engineering, UiTM Shah Alam. And today I am going to present my final year project, which entitled The Improvement of Water Flow Efficiency for Rainwater Harvesting System. My supervisor for this project is Prof Madya, Dr. Azianti, Binti, Ismail. Without further ado, let's start with the presentation. First and foremost, we start with the project summary. This project is to determine the most suitable method to improve the water flow efficiency of the rainwater harvesting system. Rainwater harvesting system is the process of collecting rainwater from declined surfaces on which rain falls and storing it for multiple uses later. The pie chart in the methodology sections highlights the reason for choosing the optimal rainwater harvesting system design. The project will be designed in SolidWorks software according to its actual measurement before running a flow simulation to assess the current performance of the current rainwater harvesting design. At the end of the project, the expected result of the simulation analysis is to determine the capability of rainwater flow from storage to the point of use and to determine the ability of the tank stand to withstand the weight of the water tank at full capacity. The project is one of the internship innovative project to be carried out in Wisma Jabatan Pengairan and Saliran, JPS Negeri Kelantan. The intent of this project is to improve the water flow rate of the rainwater harvesting system by determining the best method that should be used to transfer the water from the tanks to the point of use. The groundwater sources and aquifers are under great pressures in many regions of the world as the world's populations continues to expand at an astounding rate. By completing this project and enhancing the use of rainwater harvesting system, it can help to protect the availability of the groundwater by collecting and using rainwater, as the collected rainwater can replace the groundwater in daily domestic and agricultural use. Next, we go to the literature review. Debus et al. Stated in the Rainwater Harvesting, a comprehensive review of the literature, that rainwater harvesting system is the process of collecting rainwater that falls on a roof or declined surface and transporting it to a storage facility for later use. Natchson et al. Compared two types of rainwater harvesting methods. One, the collected water is kept in reservoirs. Two, the collected water directly penetrates into the aquifer, which is the rainwater harvesting recharge system. The study concluded that rainwater harvesting system with reservoir is suitable for rural areas, while rainwater harvesting recharge system is more suitable in high populated cities. The method that is used to transfer the water is either by letting it flow naturally by gravity or is pumped to the point of use from the storage container using pumps. As for the gravity method, to get enough force to flow the water from the tank to the point of use, the height of the tank needs to be elevated. This method is preferable as it is free energy and does not cause negative impacts on the environment compared to the pumps. Next is the problem statement of this project. The key issue with this project is the poor flow rate efficiency of the rainwater that flows from the storage to the tap end. The rainwater should come out when the tap end is switched on. However, when the tap is switched on, The water pressure is too low to be useful for a variety of tasks. The current arrangement of the height of the staging could not supply enough pressure to the rainwater due to the height of the staging being too low. And the objective for this project is to find the most suitable method to redirect the stored rainwater to the point of use, and the second, to improve the efficiency of the flow rate of the rainwater, and the third is to enhance free energy usage in line with engineering sustainable development goals. This project is in line with the Sustainable Development Goals SDG number 6, which is the clean water and sanitation. The goals is to protect and restore water-related ecosystems, including mountains, forests, wetlands, rivers, aquifers, and lakes. Second is to support and strengthen the participation of local communities in improving water and sanitation management. And the third one is to implement integrated water resources management at all levels, including through transboundary cooperation as appropriate. The next one is the scope and project limitation. The scope of this project is the improvement that can be made to the rainwater harvesting system to increase the flow rate of rainwater from the storage tanks to the point of use. And the improvement of the rainwater harvesting project has possible drawbacks, which is the project's result can only be obtained through simulation, as the actual project might take too long to be completed. This is because the project include the government institution of Jabatan Pengairan dan Saliran JPS Negeri Kelantan, and there are procedures before the project can be conducted where it should comply with the COVID-19 standard operational procedures. The next part is the methodology, and we start with the construction of pure chart. And the pure chart is used to determine the optimal design for our rainwater harvesting system. And from this chart we can see that design 3 is the most optimum, as it has the highest score of 29 compared to 16 of design 2 and 12 of design 1. And we can see that there are weightage for each criteria, and the meaning of weight for each criteria is 1 for good and 0 for identical, and -1 is not good. As shown in the figure above, the actual measurement of project parameters has been obtained and sketched roughly. The measurement was then translated into 2D drawing using SolidWorks software. As shown in the previous slides, the 2D drawing of project parameters has been designed using SolidWorks software. The 2D drawing of the actual measurement makes the 3D design and simulation process a lot easier. And these are some of the parts that have been designed in SolidWorks software. The pipe, the material is PVC and HDPE. Height from tank to the ground is 3.47 meters, and length from tank to T-junction pipe is 38.56 meters. And the tank stand, the next one is tank stand. The material for tank stand is galvanized steel, and the dimension, the length of this stand is 9.02 meters. The height is 0.5 meters, and the width is 1.56 meters. And the next one is tank support, which is placed on the tank stand to support the water tank. The material for this tank support is galvanized steel, and the dimension, which is the length is 9.02 meters and the width is 1.7 meters. And the last one is water tank, and the material for the water tank is HDPE, which stands for high density polyethylene. And the dimension for this water tank, and the maximum volume is 350 gallons, and top diameter for the tank is 1.57 meters, and the bottom diameter is 1.3 meters, and the height for the tank is 1.27 meters. After each of the parts is designed, and this is the project assembly in SolidWorks software. Rain harvesting system at Wisma JPS Negeri Kelantan. The present stand design has a height of 0.5 meters. The height of the stand is relatively low, indicating the high stability of the water tank stand. However, the water pressure is insufficient to make the water flow to the place of use due to the height, resulting in a low water flow rate. The next one is the expected results. By following all the methodology, several results are to be expected. The first one is the rainwater flow rate from the storage tanks to the point of use will increase. The second one is the stand can fully support the rainwater tank without collapsing, as the results from the simulation suggests. The third one is the galvanized steel utilized for the stand helps to prevent rust and corrosion, extending the stand's life cycle. Next one, we go to our preliminary results, and the stress study on the rainwater tank stand was illustrated as the figure above suggests. This approach may be used to assess the material failure of a design and the maximum stresses it can withstand before collapsing. This method will make the material choosing process considerably easier. If the entire surface is blue, it means that the material used can endure the weight of the water tank without being crushed. Hence, the current design of the rainwater harvesting system is strong enough to withstand the maximum weight of the full capacity water tanks. Okay, next we go to our flow simulation. The figure above shows the simulation of water flow in the rainwater harvesting system done by using SolidWorks software. The flow simulation is used to determine the present water flow rate of the rainwater harvesting system. Okay, even though there is water flow, it is very low and is not suitable for everyday use. The pipe solely uses gravity forces at a certain height to convey rainfall from the tank. The present height of the stand is 0.5 meters, which has a significant influence on the system's volume flow rate. And from the simulation, it is shown that the height of 0.5 meters is not enough to generate pressure for the water to flow and to be suitable for use. SolidWorks software may be used to generate and analyze the appropriate height for producing optimum pressure and increasing the water flow rate. This way, the water flow rate can be increased and will be suitable for use. Next, we will go to the Gantt chart. Okay, for the Gantt chart, this covers for my FYP1 and FYP2 schedule. And there are project activities and also the month here, which is to track our progress during our completion of our FYP. And in this slide here is the expected duration for me to complete all the activities in my FYP2. Okay, next we go to our future planning for final year project 2 in semester 8. Number 1, design the suggested improvement of the rainwater harvesting system using SolidWorks software. Second one is to run the simulation flow using SolidWorks software to get the most efficient water flow and completed the data analysis. The third one is to calculate the cost of the project and come out with project quotation. Next we go to the references, and this is the references which is used in this entire slides. As we can see, there is only 2 references which is used in this slide. And that is all from me, and if there is any questions, can contact me by this email here. Assalamualaikum warahmatullahi taala wabarakatuh.